Problem 6-48. Determine the force of members IJ, EJ, and CD. Now, there's no force at D, and so this is a zero force member right here. So if that's a zero force member, there's no loads, then the forces in CD will be the same as DE. So instead of solving for CD, I'm going to solve for DE. And so I can cut the member or the truss right there and solve for the right hand side. So since I want to solve the right hand side, before I can cut it, first I got to find the reaction GY. So I'll start by summing the moments about point A. So I sum the moments point A. All these forces are going to cause clockwise rotation, so they'll all be negative. We don't care about that, and it goes through point A. And the reaction at A, of course, also goes through A. So we're going to do 2 and 4 and 6 and 8 and 10 and 12 meters times these forces. So we got -5 times 2, -5 times 4, -6 times 6, -4 times 8, and -4 times 10, -2 times 12, and plus GY times 12 equals 0. So solving that, and GY equals 13.5. So now I'm going to redraw. I'm going to cut it here and redraw my new object here. And so it goes something like this. That's not good. $13.5, 2, 4, and 4. I'm going to start out by summing about point J, which is right there. If I sum about J, then these two forces that are unknown. Now this one's going to be pushing back. It's going to be in compression. These two forces are unknown, won't matter because they go through the point J. Now J is not on our object, but that doesn't matter. We can still sum about that point. So if I sum the moments about J, 4 doesn't matter. That 4 does, so -4 times 2, and then 13.5 minus 2 is 11.5, and that's going to cause positive rotation times the distance 4. And then I got the force here, so FDE, and that's going to cause negative rotation times 4. The height there is 4, and that equals 0 times 1. Oh, I didn't account for both of these because I did it about J, so I got to do 2 times that one and 2 times that one. So it's going to be 2 minus 4 times 4 plus 11.5 times 6. There we go. And so FDE equals 11.25. Now the next thing I'm going to do is I'm going to sum the moments about the point E. If I sum the moments about point E, then those two forces don't matter, and I can solve for just the x component of this. The y component of Fij, let's draw that better. So the I component will go through point E, so it doesn't matter. All that matters is the x component. So sum the moments about E. Now you might say, well, you already summed the moments. You can sum the moments twice. That doesn't give you an extra equation. That means you're not going to be able to use either the x or the y, sum of force x or the y, because they become redundant. But you can sum it twice about different points. So I'm going to sum the moments about E. And first of all, I'm going to call this is Fij. So it's going to be Fij in the x direction. That's this one. Now if we look up here, the height from here to here is 4. And it's in 3 equal parts. So the height here is going to be 2/3 of 4. So I'm going to multiply Fij and the x times 2/3 of 4. And then minus 4 times 2, that's that one. And then plus 11.5 times 4. And that equals 0. So Fij in the x equals 14.2. Going to the right. So we can solve this, find the y, because the y component here will follow the same geometry. So if we draw this little triangle up here, this right here is 1/3 of 4, and this right here is 2. So if we do Fij in the x over Fij in the y, that's going to be the same as 1/3 of 4 over 2. So Fij in the y equals 21.4. That's going down. So last I'm going to solve the forces in the x direction. So if I sum the forces in the x direction, I've got that force, the horizontal of this force, and the horizontal of that force, Fij in the x. So FDE is to the left, and that was 11.5, so I've got negative 11.525, and I've got positive 14.2, and I've got negative Fej in the x direction, and that equals 0. So we can solve for Fej in the x, and that is 3. Now if we look at the geometry here, the length here is 2, and the height here is 4. Therefore, we know the vertical component will just be twice the horizontal component. So Fej in the y is equal to 6. And we could do Pythagorean's theorem to find Fej to be 6.7. So we found the 3 forces, and by looking at this, FDE is pulling in, Fej is pulling in, so those are both in tension, and Fij is pushing out, so it's in compression.